Hello friends, I am Shaurya Mishra, your Vision Care Advisor. Welcome you to your own YouTube channel, Vision Care Advisor. Today, we will talk about Jackson Cross Cylinder. In short, we are also called it JCC. In this video, we will talk about all the things regarding Jackson Cross Cylinder. As you can see the duration of this video, I have covered all the things so that all of your queries can be resolved here at a place. We will discuss why it is called Jackson Cross Cylinder, types of Jackson Cross Cylinder, what is the principle of Jackson Cross Cylinder, how to do the Jackson Cross Cylinder, etc. Friends, before starting the video, if you like our content, please do like, share and subscribe our channel and press the bell icon so that as soon as our new videos comes, you will get the notification. So let's get started. Friends, firstly we will discuss about the types of Jackson Cross Cylinder available. Friends, there are 4 types of Jackson Cross Cylinder available, that is 0.25 diopter cylinder, 0.50 diopter cylinder, 0.75 diopter cylinder and 1 diopter cylinder, in which the most commonly used JCC in today's time, that would be plus minus 0.25 diopter cylinder and plus minus 0.50 diopter cylinder. So now let's see when and which power of JCC you should be used. Friends, after correction of spherical lenses, if the vision is 6/9 or better, you should use plus minus 0.25 diopter cylinder. If the vision is 6/12 or worse, you should use plus minus 0.50 diopter cylinder. If the vision is 6/24 or worse, you should use plus minus 0.75 diopter cylinder. If the vision is 6/60 or worse, you should use plus minus 1 diopter cylinder. You can use it with the minus and plus also, but whatever you are using, you have to take the cylinder of double with the opposite sign. Suppose if we are using plus 0.25 diopter sphere, then we will have to use minus 0.50 diopter cylinder. If we are using minus 0.25 diopter sphere, then I will have to use plus 0.50 diopter cylinder. If we are using plus 0.50 diopter sphere, then I will have to use minus 1 diopter cylinder. If we are using minus 0.50 diopter sphere, then I will have to use plus 1 diopter cylinder. So these 4 combinations that we are using in the Jackson Cross Cylinder. Jackson Cross Cylinder is a combination of minus and plus cylinder power, the same power located perpendicular to each other. The axis of 2 cylinders is marked in white dot and red colors. The white mark indicates the axis of plus cylinder and the red indicates the axis of minus cylinder. Now, why it is called Jackson Cross Cylinder? The name Jackson comes from because of the famous scientist Edward Jackson. Cross because we are using the flip cross technique, flipping one side to another side. Cylinders because it is used for refine the cylindrical correction. It is used to refine the cylindrical axis and power correction, that is astigmatism. Now, what is astigmatism? Astigmatism means when the power is different at least in two principal meridian, and when the power is same in all the meridian, that is called the spherical correction, such as simple myopia or simple hypermetropia. But here we are talking about the astigmatism, that the power should be different in two meridians, such as horizontal and vertical. Suppose horizontal meridian is A and vertical meridian is B, and the power should be different in both the meridian. For example, if horizontal meridian power is 4 and vertical meridian power is 1, so it is astigmatism. But if the horizontal power is 1 and vertical meridian power is also 1, so it is not the astigmatism. Simply, if the horizontal power is 1 and vertical meridian power is 0, so again it is astigmatism, because the power is different in both the meridian. Jackson cross cylinder is a type of toric lens used during the refraction. It is also known as flip cylinder because when we are using it, we are flipping it from one side to another side, and this technique is called flip cross technique. The original concept of crossed cylinder was described by Stokes in 1849, who combined cylinders of +4 diopter cylinder and -4 diopter cylinder. But its use was popularized by Edward Jackson in 1907 and often referred to as Jackson's cross cylinder. The cross cylinder is a combination of two cylinders of the equal strength but with opposite sign placed with their axis at right angle to each other. It means they are at an angle of 90 degree to each other and mounted in a handle. So now you should know that how it is happening. The cross cylinder is a spherocylindrical lens in which the power of cylinder is twice to the power of the sphere, and with the opposite sign also. It means the power of sphere is equal to twice of the cylinders with the opposite sign. For example, if we take plus 0.25 diopter sphere, which consists of a sphere and a cylinder. If we take plus 0.25 diopter sphere, so the cylinder would be double of it with opposite sign, that would be minus 0.50 diopter cylinder. So what will be that it will give? Friends, take one is a horizontal and another will be the vertical. Now we are taking plus 0.25 diopter spherical. Spherical means equal power in all the meridians. So plus 0.25 diopter sphere would be at vertical and horizontal also. Now as cylindrical is minus 0.50 diopter and cylindrical is acting as a particular degree. Suppose cylindrical minus 0.50 diopter will be added at horizontal only. So now vertical is plus 0.25 diopter sphere and horizontal will be plus 0.25 diopter sphere with minus 0.50 diopter cylinder. that would be minus 0.25 diopter cylindrical. So now vertical is plus 0.25 diopter sphere and horizontal will be plus 0.25 diopter with minus 0.50 diopter, that would be minus 0.25 diopter cylinder. So finally we are going to get two cylindrical with equal power of strength but in opposite sign, that would be plus 0.25 diopter cylinder and minus 0.25 diopter cylinder. So that's why we are able to do flip cross technique. Once we are putting the power of plus sign, then we are flipping it, and that is also the same power with opposite sign at the angle of 90 degree. Another important thing is that the lens is mounted on a handle which is placed at 45 degree to the axis of cylinders. It means the angle between these two cylindrical, that is 45 degree. Now we will have to understand what is the principle of JCC. Principle of Jackson cross cylinder is collapsing of the STURM's conoid. Friends, we will discuss in details about STURM's conoid in next coming videos. But now let's know STURM's conoid in short. As we know, in astigmatism, when the parallel rays of light coming from infinity is focused at 2 points at retina, which is perpendicular to each other, so when they are forming the focal lines, they are not coming to focus at one point. This is conical pattern of the rays which is formed, that is called the STURM's conoid. So what happens when the rays of light traveling through a astigmatic surface or toric surface, that optics can be described through the STURM's conoid. In this pattern, there is a circle of diffusion or circle of least confusion which is falling at outer limiting membrane of the retina, and this is coming in the mixed astigmatism. Now what is the goal? Friends, our goal here is to place the circle of least confusion on the retina to creating the mixed astigmatism in order to find out the exact axis and the power. Friends, how do we know if there is any astigmatism or not? First, you have to know whether there is astigmatism or not. Then, you have to know what is the axis and what is the power. Friends, if you have no idea whether this patient have any cylindrical power or not, so in this case, you can take the JCC and put it at 90 degree and then at 180 degree. Then you can observe whether the vision is improved or not, or is there any deterioration. So you will get an idea that is there any astigmatism or not, and if there is any preferred position as shown like 90 degree or 180 degree. If you find a preferred flip position, then start adding the cylinders. If you finding a preferred flip position, then start adding the cylinders first in the axis, which is parallel to the respective signs like dot. Then you can change the sign by flipping the JCC. You have to keep on adding those until the two flip choices become equal. Now, suppose if there is no preference is found, then you should have to check two more angle and put it the JCC at 45 degree and 135 degrees. And now if you are not getting any preference or any particular axis amongst at 4 important and standard axis, that is 90 degree, 180 degree, 45 degrees and 135 degree. It means the patient doesn't have any astigmatism and he will give the equal correction of all the 4 axes, that is spherical only. Now coming to the refinement of the axis. After confirming that this patient has the astigmatism, then always remember that you have to confirm the axis of the astigmatism first, then power of the astigmatism, because if you have the wrong power, the correct axis can be found, but if you have the wrong axis, you can't calculate the right power. So always remember to check first with the axis and then the power of the astigmatism by JCC. You should take the JCC before the eye and keep its handle where the power is placed at 45 degree in the JCC. While doing the JCC, the target to show the patient should be Snellen chart or multiple dots at 6 meters or 20 feet. Occlude one eye first and process the JCC. The handle should be parallel to the axis of the trial cylinders, and then flip the JCC to give the choice of 2 position, and the patient should be asked to tell which positions, dots or visual acuity seems to be clearer. And if there is no change in the visual acuity and patient notices no difference between the 2 positions, it means axis of the correcting cylindrical in the trial frame is correct. For example, suppose you have given the power -1 diopter cylindrical at the axis of 180 as per your retinoscopy value or autorefractometer value, and patient notices that there are no changes in the visual acuity, it means the axis of 180 is correct. But if the patient notices some differences and tell us that position 1 was better, then the better position would be preferred and add or subtract 10 degree according to the preferred choice. Suppose the axis is 180 and you put the JCC handle parallel to the given axis and position 1, whatever it is, either plus or minus. The position 1 is towards the clockwise. It means towards the axis of 170, 160, 150, etc. And the position 2 would be anti-clockwise. It means towards the axis of 10 degree, 20 degree, 30 degree, etc. And ask the patient which position is more clearer. And the patient experiencing the position 1 is better, that means you have to subtract 10 degree from the axis of 180 and now rotate or shift 10 degree towards that side and the axis would be 170. Do the same things till the reversal has come. Friends, reversal means if you give the 2 option, that is position 1 and position 2, and patient prefer the same position 1, and again after asking which one is more clearer and he again prefer the position 1 is better, and patient experiencing the same things 2 to 3 times or more and then he experiencing now the position 2 is better, that is called the reversal. It means if he again saying the same thing and after saying the same things, now he said that now the previous one was better, it means the reversal has come. And after finding the reversal or both seems to be similar clearer or similar blurred, you will get the astigmatic axis. The process is repeated until the patient says there is no further improvement and the given trial cylinder is in the correct axis for the eye, and do the same process for the other eye also. And this is the right axis for that patient by flip cross technique. Now coming to the astigmatic power refinement, and in this putting JCC with his axis dots white and red parallel to the axis of the cylindrical in the trial frame. You will do this first with the same sign and then with the opposite sign by flipping the JCC. If the patient doesn't experiencing any changes in the visual acuity either with plus red dot or with the minus green dot, that means the patient is having the accurate power in the trial frame. But if he is feeling that red dot is better, then you will have to add plus 0.25 or plus 0.50 according to your JCC power value. If the patient says that the green dot is the better one, then you have to add minus 0.25 or minus 0.50 according to your JCC power strength value. So you will have to do it until unless there is no further changes in the vision or until reversal has been found. If there is no further change in the visual acuity in either of the position or when getting the reversal, then that is the correct power of the trial frame. If the visual acuity is improved in any of the position, then the corresponding correction should be made, and when found there is no more further changes in the visual acuity with your flip cross technique, so that would be the power of your astigmatism. For example, friends, I'm giving you the example to do the whole technique of Jackson cross cylinder. Friends, just assume that if a patient came to you and you have done the autorefractometer or retinoscopy and the refraction value is minus 2.50 diopter sphere with minus 1 diopter cylinder at 160 degree. Friends, after doing the objective refraction by retinoscopy or autorefractometer, you have to give complete spherical correction first, then put the cylinder power in the trial frame and rotate the 20 degree, add or subtract as given axis by your autorefractometer. Suppose if the autorefractometer is showing 160 degree, then you will have to put the axis in the trial frame by 20 degree rotation, that would be 180 degree. Now JCC handle would be parallel to the axis and ask the question to the patient that there is a multiple circular dots and I'm going to show you two position, and kindly let me know which position is more sharper and clearer, and show the patient to position 1 on the parallel to the axis, then flip the Jackson cross cylinder and show the position 2. Suppose position 1 is white dot and it is towards the clockwise, it means towards the 170 degree, and position 2 is red dot and it is towards the anti-clockwise, it means towards the 10 degree. If the patient said that position 1 is better, then rotate 10 degree and that would be 170 degree. Then again show them two positions and ask the same thing. Then again patient is saying that position 1 is better. Then again rotate 10 degree and the axis would be 180 degree. Then again show them two position and now the patient said that both are similar clarity. Then now you find the axis and the final axis would be 180 degree. Now coming to the refinement of the power of cylinder. Friends, before refining the power of this example, I want to share with you some fact, as I have told you earlier that if you are using 0.25 diopter cylinder JCC, the power would be plus 0.25 diopter sphere with minus 0.50 diopter cylinder at 180 on white dot, and plus 0.25 diopter sphere with minus 0.50 diopter cylinder at 90 degree on red dot. If you are using 0.50 diopter cylinder JCC, the power would be plus 0.50 diopter sphere with minus 1 diopter cylinder at 180 on white dot, and plus 0.50 diopter sphere with minus 1 diopter cylinder at 90 degree on red dot. Friends, always remember that if you will be increase minus 0.50 diopter cylinder in the cylindrical value, then you will have to add plus 0.25 diopter sphere in the spherical value. Now coming to the example, friends, as the power is having minus 2.50 diopter sphere with minus 1 diopter cylinder at 180 degree, in refining the power of cylindrical, the process would be same as done to refine the axis of cylinders. But now here the dots of JCC would be parallel to the found cylindrical axis, while in defining the axis, the JCC handle was parallel to the axis. Suppose if you are using 0.50 diopter cylinder JCC and position 1 is white dot and position 2 is red dot, and you will be showing two positions by flipping the JCC, and confirm with the patient by asking which position is more clearer and sharper. If patient said that position 1 is better, it means the white dot position is better. So now you will have to add minus 0.50 diopter cylinder. It means you have to add minus 0.50 diopter cylinder in minus 1 diopter cylinder as in the given example, and it will be minus 1.50 diopter cylinder. Friends, as I have told you that after adding minus 0.50 diopter cylinder, you have to add plus 0.25 diopter sphere in the given spherical value. So you have to add plus 0.25 diopter sphere in minus 2.50 diopter sphere, and the spherical value would be minus 2.25 diopter sphere. So now we find the power till this step, that is minus 2.25 diopter sphere with minus 1.50 diopter cylinder at the axis of 180 degree. Now do the same process again to show the two position by flipping, and if the patient said that again position 1 is better, then you will have to add plus 0.25 diopter sphere in minus 2.25 diopter sphere and minus 0.50 diopter cylinder in minus 1.50 diopter cylinder, and the power would be minus 2 diopter sphere with minus 2 diopter cylinder at the axis of 180 degree. Now do the same process again, and if the patient experiencing the same clarity in both the position, that means you have find the correct cylindrical power. So now the final power would be minus 2 spherical with minus 2 cylindrical at the angle of 180 degree. Friends, if you have still any doubt, please leave your query in the comment box. Thank you for watching. Please do remember to check your vision yearly and see the world clearly.